In the last video, we saw the difference between normal coding and OOP. Normal code works fine when the programs are small, but when things grows, it becomes hard to manage. That's where OOP helps. It makes our code clean, reusable, and easy to understand. Now, let's look at the core idea of OOP, classes and objects. These are the building blocks of writing smart and real world logic in Java. This is the foundation for everything we'll build in Java and in most real world projects. The main goal of OOP is simple, writing code that clean, reusable, and well organized, not just for you, but for teams and future version of your app. And it all starts by learning how to model real life things like products, users, or vehicles using classes and objects. In this video, we'll build one simple program from scratch, step by step, and inside the Eclipse. This is the foundation for everything we'll build in Java and in most real world projects. The main goal of OOP is simple, writing code that clean, reusable, and well organized, not just for you, but for teams and future version of your app. And it all starts by learning how to model real life things like products, users, or vehicles using classes and objects. In this video, we'll build one simple program from scratch, step by step, and inside the Eclipse. Let's talk about common mistakes. When we start coding, we often just use variables and functions separately. And honestly, that's okay for small programs. But in real world apps, it doesn't work. The data ends up scattered all over your code, logic gets copied again and again, and there's no way to connect the data with the action that belongs to it. So even small changes becomes frustrating because nothing is grouped, nothing is reusable. Alright, let's break this down in simplest way. An object in Java is something that holds both data and behavior in one place. Think about a phone. Its data could be brand, mobile, price, its behavior, things it can do, like making calls, playing music, and taking pictures. In Java, we bring all of this together using something called an object. So instead of handling everything separately, we group it, just like in real life. So now you know what an object is. But how do we actually create objects? That's where a class comes in. A class is just a blueprint, a design or template. It tells Java what every object of that type should contain, and like a DNA. If you create a class called product, it defines that every product will have the name, price, and some actions like applying a discount or showing the details. In short, the class is the plan, and the object is the real item we build using the plan. Let's build a class step by step, just like we'd build a real product. First, we add the name so that each product know what it's called. Then we add the price because every product needs a cost. After that, we add a method called apply discount to reduce the price when needed. And finally, we add displayProduct, a method to show all details of that product on screen. This setup makes our class complete. It has both data and behavior grouped in one place and ready to create an object from it. Now, let's bring the blueprint to life. We use this line in Java. Product P1 is equals to new product. Let's break that down. Product is the class, the blueprint we just created. P1 is the object, the real product, now stored in a memory. New is the keyword that tells Java to create the object and runs the constructor automatically. This process called instantiation, which simply means creating the real object from a class. Let's compare the two again. A class is the definition, like a blueprint of a car. It tells what every object should have to do. An object is the real thing, like your actual car parked outside. It's built using the blueprint and it lives in memory when the program runs. Now, when we use an object method like p1.applyDiscount, p1 its object, applyDiscount is method we created in class. We are using behavior that's directly tied to that object's data. And this is exactly what we call encapsulation, keeping the data and the behavior bundled together in one place. Everything around us is an object, your phone, your car, even your books. All of them are called real world objects. Each one has two things. One is data like name, model, size, and behavior. Things it can do like turning on, accelerating, flipping the pages. That's exactly how we think in object oriented programming. Java lets us write programs by following the same pattern in real life turned into code. Here's another easy example. Let's say we create a class called car. This class can have two parts. One is state, things like speed and fuel level. And second is behavior, action like accelerate and brake. Now using the class, we can create a real object like this. So again, the class is just an idea or blueprint, but the object is the real usable car, like the one you drive. So here's exactly what we're building in this part of the video. We're going to create a product class with the three main things: a variable for product name, a variable for price, and two methods. One is apply discount and display product. That's it, simple and clean. But this structure, it forms a base of every Java project you'll build in future, whether it's an app, a system, or a coding run question. Alright, enough theory. Time to open Eclipse and build everything live. We'll write the full class line by line. We'll create real objects, apply logic, and see the output right on screen. And don't worry, I'll explain every step in a simple way. Alright, let's start from the right beginning by opening Eclipse. If you already installed it, just go ahead and launch the app. Now, it might ask you to choose a workspace location. Don't worry about that too much. You can leave the default or choose any folder where you want your Java files to be saved. Once Eclipse opens, we're good to go. Now, let's create a new Java project. Think of like a fresh folder where we'll write our all codes. Click on the top menu, File, New, Java project. Then give your project name. I'm calling mine as OOP series, so we can keep all our videos organized in one place. Once you named it, hit finish. Inside that project, we need to create a Java class file. This is where we'll actually write our code. So go to the source folder, right click, new class. Now give your class name. You can name it main or something like a product demo. And super important, check the box that says public static void main. This tells Eclipse to automatically add the main method, which is where our program start to running. Then just click it finish and we're all set. Nice. Now we're inside our Java file and this is where the fun begins. We're going to write our first real class and create objects and see how OOP works in real action. For example, we'll keep it simple. We'll write both our class and the main method inside the same file. Alright, let's start writing our first class. In Java, a class is like a custom data type or blueprint. It helps us to group related data and behave it together, just like our real world objects like phones, laptops, cars have both properties and actions. This is why we use OOP to model real things using clean code. We use the keyword called class followed by the name of the class. The name should always start with the capital letter. That's a Java rule. Here am I. Here I'm calling it product because we're going to represent items like a phone or laptop. Inside the class, let's define a few variables. These are all called fields or attributes. They represent the data each product will hold. We use string data type to store text like the product name, for example, phone or laptop. Then we use double to store decimal values because price usually have decimal points like 999.99 or 4990.50 like this. Now, let's create a constructor. This is special method that gets called automatically when we create an object. The constructor name must be exactly match the class name. So here it's product and it doesn't have a return type, not even void also. It just silently runs when object is created. Inside the constructors, we assign the values passed as a parameters to our object's variable. Same with price. We take the cost value and store it in the object's price variable. Now, let's create a method called apply discount. This method will reduce the product's price based on the discount price we give. We are using void because the method doesn't return anything, it just performs an action. First, we calculate the discount amount using the simple formula price times percentage divided by 100. Then we subtract the discount from the original price and store the new value back into the price variable. Let's add one final method to display the product's name and updated price. Again, we are using void because not returning anything, just printing the screen. We use system.out.println to show the result. and the plus here is used to join the text variables. This is called string concatenation. That's it. We now written a full Java class with the variables, a constructor, and now two methods. This structure is neat, reusable, and perfectly ready to create an object from. Alright, we are done building our product class. Now it's time for actually use it. This is where Java running your code inside the main method. We create a class called main. Why main? Because the file and public class name must match in Java. For example, if your class file name is product, the public class name must be product. Inside that class, we'll define the main method. This is the entry point of any Java program. Let me quickly break it down. Public means this method is visible to other classes. Static means we don't need to create an object to run it. Void means it doesn't return anything. Main is the method name Java looks for. String args is used to take input from the command line. We'll ignore that for now. Now, let's create our first very product, a phone that costs 10,000. We use the new keyword to create an object for our product class. This line sends the constructor we wrote earlier and assigns the name and price. Let's create another object, a laptop priced at 50,000. Now, we have two real objects, P1 for phone and P2 for laptop, each with their own unique data stored inside. Now, let's apply some discounts because, hey, who doesn't love saving money? We are giving a 10% discount on the phone, so its price drops from 10,000 to 9,000. Then we apply a 15% discount on the laptop. 15% of 50,000 is 7,500. So the new price will becomes 42,500. Now, let's print the updated price on the screen using our displayProduct method. And this will show the final result on the console. Super clean and beginner friendly. Alright, let's take a look at the output on the console. First line says, phone now cost 9,000. That because we applied 10% discount on the original price of 10,000. So the discount was 1,000 and final price becomes 9,000. Next line. Laptop now cost 42,500. This one had 15% discount on the 50,000. 15% of 50k is 7,500. So the final price becomes 50,000 minus 7,500 is equal to 42,500. Clean, right? We didn't repeat any code, didn't copy paste formulas. We just created objects, gave them data, and called methods. That's the real power of Hoop. Each object handles its own logic. No confusion, no chaos, just clean and reusable code. And this wasn't a just dry theory. We wrote real code that models real world logic. If you followed along till here, you're already ahead of a lot of students. But we're not stopping here. In part 2, we are going to apply all of this to a real hacker-rank challenge. The question is called classes and object. If this video helped you even little, give it a like and share it with your friend who learning Java too. And if you're new here, don't forget to subscribe. We got more easy videos coming in this series. That's all for now. See you in the next part, where we solve the real question from hacker rank using classes and objects. Until then, keep learning, keep coding, and signing off, Chad.